Yeah, thank you very much. I hope you're having a good day. And first of all, I need to apologize because I'm kind of coughing today. Hopefully, well, as far as I know, it's nothing contagious because my wife and my daughter is still fine. But if that's going to be distracting, I apologize in advance. So let me quickly talk a bit about myself. So, I'm probably best known as the guy who created Jenkins. And I consider that to be sort of like my left arm. This is an open source project that's been around for quite some time, used everywhere around the world. And helping teams, hopefully like yours, everywhere, helping software development. Now, there's another arm of myself, which I consider the CloudBees. So this is the company we built around Jenkins, and it's the #1 sponsor of the Jenkins project. And we are helping enterprises like everywhere doing DevOps transformations, help them do a better software development at the organizational level. So I kind of see those two things as my two arms. They have a different reach and impact, and so on and so forth. So, I've been pushing the automation forward by using those like my two arms. And I think we came quite a long way, right? I still remember the day in some microsystems where, the nightly build used to be a new thing. So compared to that, today we probably have, how many people have, the pipeline like this that goes from, the source code to production. Actually, not many hands. I'm starting to worry a little bit here. But actually, for those of you who said yes, I'm pretty sure what's actually going on is probably more like that, right? Like, you don't have that kind of clean picture. Or if you think you are, then you're probably missing what's happening to your left, as in like who are producing all these libraries and so on and so forth. To stuff that's happening to the right, you produce these bits, Docker container, and then you hand it over to quote-unquote operations team or SRE team, and you actually don't know what's going on there. So, and then the good thing, well, at least the progress is that most of these activities are automated, right? Like it's somebody's script running somewhere doing some stuff. You just don't know where that exists and what it's doing. Hopefully no humans are involved in this process. But because of that, like when you actually try to understand what's going on, you sometimes feel like trying to understand where the activity of the beehive is by trying to look at the individual bees going left and right. And there's just so much activities going on. So much data is getting produced. And then it's just such a low level that it's impossible for any humans to make any reasonable sense out of it. So that seems to me like a problem. And after seeing so many companies, I felt like, well, so many companies have this kind of problems. Now, I get to, one of the joy that I get to because of my privilege as a creator of Jenkins is I get to go see lots of software development teams around the world, and they tell me interesting challenges that they're facing and what they've achieved. And as I was looking at these things, I started feeling like there's this distinction between what they think as donkeys versus unicorns. I mean, they have both 4 legs and so on, but that's where the similarity ends, and there seems to be a huge difference in the productivity and so forth that they have. And then so I started to develop in this hypothesis that what seems to be, at least one factor of what seems to be differentiating them is how they use data, like the ones that all this automation is producing. And then how they are using that to, to make an impact. Another way to look at this is, I've heard, and I don't know if this is actually true or not, but all this e-waste, all these computers that's been thrown away, and the former Sun guy kind of sad to see some Sun hardware in there. But apparently I've heard that the by weight, this e-waste contains more gold than the gold mine. So it's actually more it's actually more profitable. That's the word I was looking for. Thank you. To mine those things as opposed to the actual dig up the land. So I think there's this is kind of how I started feeling when I was looking at all these automation that the people are doing. It's actually producing lots of useful data, but by and large, that's getting thrown away without people not using anything. But I really feel like it can be defined and then turned into actionable insight and intelligence that's going to help people move forward. So just to give you, so that's kind of abstract things to say. So I wanted to give you a few examples to make this a little bit more concrete. So first example that I brought up is coming from one company. So they have, imagine like a software company with hundreds of engineers running tens of the projects, and they have one. they have one team that's providing this shared CI infrastructure. Right? They happen to be running Jenkins, but that's kind of beside the point. And this team is providing this, the automation infrastructure for every project to put the workload on. And they're spending hundreds of thousands of dollars per year for AWS. Now, this was a pre-IPO company in the Silicon Valley, so the last thing they were worrying about was the cost. So that's fine, like $100K in AWS, that's like a chump change, until they started thinking about the IPO. So a new CFO shows up, and they look at the bill from Amazon. Well, it looks like, so all this money that we are spending, it could be fine, but at least we gotta be able to tell what impact it's creating. Like, is it actually valuable? What is this money exactly being spent for? And this release engineering team got thinking, well, actually, we have no idea. Like, we don't know who is using all this workload and what impact it is creating. So what should have happened, or what they are actually trying to do, was to provide the visibility of the cost at the project level. See, so what's happening was, as this shared infrastructure service, they're providing the ability for the project team to choose between one of the three VM sizes, the small and medium and large, let's say. And then these, obviously the smaller ones are cheaper, but the project team, doesn't see the cost, so they don't care about the cost. So they have no incentive to keep things small. So whenever they first sign of any, like a flaky test or a race condition or something, the automatic reaction from the developer is, I'm gonna just bump up the VM size to bigger, because why not, right? And then they just start racking up the money. So what instead we should have been able to do is just give them, imagine if you can give a slider for the developers to choose, right? You have three sizes that comes with a different cost, but obviously the bigger ones provide you the faster turnaround time. So that allows the project team to actually make intelligent decisions. Like, this might be a pull request build, in which case you probably want to be a fast one, so that makes sense. But if it's like a nightly test execution or like a long test suites that's running behind the scene, then it's probably okay to go to the smaller ones and so on. Or if the things that's running along that actually you're not actually using it, you'll be incentivized to turn it off. So this would be like a kind of very obvious, like an insight that the data could provide that drive people's actions at the ground level. Yet too many people are not even doing something like this. So another example, so this one is like a much larger company in Europe. They have thousands of engineers working on a single massive code base together, right? And they'll still have the one DevOps team that runs the entire CI/CD infrastructure, which is kind of amazing at this scale. So the problem that these guys has is, imagine like one of these engineers have some workload and the build fails. And then they want it, so the question is who should be notified of that failure first? So what was going on is that if the failure was because of the, let's say the problem in the source code or legitimate regressions, then it's the application developer that should be notified. But from time to time, the build started failing massively across the cluster because of some infrastructure problem. Right? So let's say, the connectivity to the Artifactory is down, or their internal GitHub enterprise is having a maintenance. Then across the board, the whole thing fails. And then when that happens, and if it's the application developer gets notified, they'd feel like, whoa, this is not a problem. Like, what are you doing? Like, oh, you guys run the crappy infrastructure. So the DevOps team would lose the credibility in the face of application developers. And that means a lot to them, right? Because it's this credibility that allows them to influence the application development team. So what they wanted to do is to be able to do some intelligence on who gets the first notification. Is it an infra program or is it the app program? So what they were very proud to tell me was, okay, they came up with a set of regular expressions. That's like, the technology that's been around for half a century. And then even that was still pretty effective, so I was impressed with that. And then I heard from another smaller team who was deploying a Bayesian filter. And if you've been around for long enough, you have probably seen this technology used in your spam classification in your email client, right? So they try to, you kind of have to teach them over time, like which way this would go, but the algorithm would start to pick up like which keyword to look for, and eventually it gets to a reasonable accuracy. So the genius in what they've done is, when they send out the notification, they added a button that said, this is not my problem. So that was teaching the system. Like if it sent the email to the app developer and the app developer said, no, this is not my problem, then the algorithm would learn, okay, I guess I should send it to the DevOps team. So again, well, one, it's great that it's great that these people have done it. But I was sort of awestruck by how simple these solutions are, like something that we've known for at least a decade or half a century, still not being applied by and large, and people are still getting emails. I'm sure you have experience of getting this email notification for things that you feel like, no, this is not my problem. Right? So imagine the productivity gains that can come out from things like that. Another little more involved example, but I think it's still very much relevant in perhaps even more places, is this one. So now imagine, say, like 80 people-ish strong. This was a startup in Los Angeles, so it's like 3-4 years into the game. So the reasonable guys, they have tens of microservices getting promoted between different environments at a reasonable pace. So when that happens, like the challenge is, well, so they are kind of ahead of the curve in terms of, they say continuous delivery, right? So at least they are not like doing a monthly release or anything like that. So in this kind of development model, so the challenge that they have is the people, let's say the designers or product managers or the customer, like customer manager who is tracking a specific bug fix to the system, they wanted to know when their system is getting to the production. So designer might be looking for his change coming into the UAT environment so that he can review it. Maybe the developer is looking for her change to go into the development environment to make sure when the tests that she thought might fail passed. So getting that kind of contextual insight into where my changes are when people are dividing up the different portions of the software development lifecycle, that was becoming a problem. So I started noticing that over and over. So we've done, essentially so we built this. This eventually became a product, but so we thought, well, let's compute the value stream map out of all the activities that's happening. Because if you think about it, like Jenkins is touching all these automations in various places. So we got to be able to compute what changes. So these numbers that's showing up in the circle is basically tracking tickets in Jira. So that allows, we can look at different data from different sources and basically assemble the information at this level, which allows people to say, say if you filter things down by my name, then I get to see all the tickets that I've been touching and whether they are very, left-hand side, which is a unit testing. So they are not yet into any components. And then the next one is like a component level build. And then that gets aggregated into environments eventually for the production. So having this kind of level of access to where my changes are in the space, like where in the pipeline is kind of getting stuck, I thought that'd be pretty useful. And then so this, I think I'm feeling great. Well, so we got a lot of traction on this. So, and then perhaps more important, so these are 3 examples of kind of like an interesting use application of data, some very primitive from regular expression to some a little more involved, like the body stream mapping exercise. That takes some quite a bit of counting of the data. But perhaps more importantly, I think sort of like a universal problem that's facing DevOps leaders around the world is this feeling of, we want to improve the software delivery process, but often these people struggle to get the organization rally behind them because what they believe to be the good thing isn't getting bought into by people who control the parse or the people. So sort of I started feeling kind of a renewed sense of importance that the data could bring, in the sense that, it's not enough for you to strongly insist that we have to do this, right? You need to be able to make a convincing story in ways that your boss will understand, and they're quite right to ask you for more than your belief, right? So data and the story that it tells needs to help your boss see the problem. Need to help your boss see the problem that you're seeing. And I think we tend to kind of go sort of we tend to do hand waving on that front more often than we should. And I think another important use of the data as a leader of this effort is that, you think this is where the problem is, but you owe it to yourself and your team to actually show it to yourself. This is actually the source of the problem. And I don't think there's any other way around doing data. And then finally, if you're trying to lead the effort like that, you have to be able to show that the investment in terms of time and money and people are producing the impact. Because if it's not, then you got to change something, right? So I think data also plays an important role in showing the impact of the work that you're making, which in turn enables the next round of investment into the effort and so on and so forth. And this is actually like in any business, this is basically happening everywhere. Marketing, sales. Somehow, I think the software engineering. It's kind of like this is a confession of myself, but we tend to lean on, we tend to believe in ourselves, we tend to believe that these things are self-evident, and then we tend to go too easy on not trying to make a reasonable case to other people. Now, in other words, so what that means is we really need to get to is, if you think about the software development as a factory, which is a kind of time-old analogy, perhaps. But the idea being, from the left-hand side, the ideas and the business inputs would come, and then from the right-hand side, the functioning software would come out. Then all this is saying is that we kind of need to have this feedback cycle built into this process, where we get the data out of this manufactured software factory, and we use that to drive improvements in the process itself, right? Otherwise, known as Kaizen in the manufacturing and so on. So I think it's been, we've been saying for decades that a software factory and so on, but this still very much, I think, is true. Now, there are a few companies where they started taking this to the next step. Now, let me step back. So wherever, right, so my pitch generally is this process of software factory needs to be more data-driven, and then the feedback cycle, therefore, is basically crunching lots of data and then using that to drive actions and actionable intelligence. So there's nothing, and then there's this obvious trend that's going on in the broader industry today for this kind of thing, which is the machine learning and the quote-unquote artificial intelligence, right? As a geek, I kind of roll my eyes to say this is our AI. But the general idea is, I think, it's still very relevant. That is in some cases, you can even remove the humans from this decision-making loop and then create this self-improving systems. So I wanted to quickly introduce a few examples where I was really impressed by some people who've done it. So the one is what I call the smarter test selection. So the picture that I want you to have in your head is, you're the DevOps team of this a massive company who have thousands of engineers working on a single monolithic code base. And it's a massive code base. It's modularized, but it's still massive. It's a tons of dependency between them. So, you have accumulated tons of tests. So if you try to run all the tests on all the changes, it's simply going to blow up your AWS cost to the impossible range. So what you want to do is, how can you cut the cost and time out of the software development process without reducing the quality, right? So the step one they have done, which is kind of, if you think about it, it's kind of obvious. You look at the dependencies between different modules. So, and then let's say the thing that has changed is here, then you'd be able to say, well, all right, so anything that depends on here is probably needs to be tested to be sure, but stuff over there, they don't need to be built or retested. So, with efficient caching and whatnot, you can imagine that you could substantially cut down the execution of tests. So that's like a static analysis of the build dependency to drive the subset of the work. And that this is already kind of ahead of the game for most of the teams that I get to see, which simply runs everything every time. But what's amazing about this company is that they didn't stop there. So what they thought was, again, this is, if you're a software developer, I think this should be kind of intuitively obvious that when your change is small, most of the tests that you're going to be running is going to be totally a waste, right? You know that these tests are not going to catch any problem because it's simply exercising a different part of the system. But it's just that you don't know exactly which ones are useless and which exact ones are exactly useful, right? So what they decided to do instead is just train the machine learning model out of some of the changes that they are running through the system. And this machine learning oracle, basically, every time they see a change, then they choose the right subset of the test, and then they just run those. So what they reported was, so they deployed the model of algorithm where they select about a third of the tests. And then, they were able to cut their AWS cost in half, which is, in their case, since this is a massive company, saving in the range of millions for sure. And then whenever you skip the test, like you always wonder, well, do I get to catch all the regressions that the test is supposed to catch? So they are tracking that with real care, and they reported that only 0.1% of the confidence loss. I mean, the 0.1% of the change was slipping through that they are not supposed to. And if you think about the fact that, here's all the change that's going to blow up in production, and imagine like how much of them you actually get to catch in the test. Probably here, maybe here, right? It's not that much. So the 0.1% that you're losing is just about here. So basically margin of error. So practically speaking, what this means is like, they didn't have to waste any quality in order to cut the AWS cost by millions. So that's pretty amazing. And another amazing things about this is like they didn't even do any of the sophisticated machine learning stuff that's been developed in the past 10 years. This is like any graduate level machine learning stuff, aka the decision trees. So I think I'm already running out of time, so I'm going to have to skip some of these rest of the parts. But those are kind of like a great example where I think the sort of like people ahead of the curve are doing. And this kind of got me really paused, because I used to think, because I work for the smaller company, I sort of, there's the pride of the smaller software development team is like, we are a small team of the capable people, and we can work a lot more nimbly. And compared to this large company, who might have, lots of resources and money in the war chest, but they move so slowly, right? And they just can't do it. They just can't seem to get any acts straight. So that was like a David and Goliath picture. But this kind of like using data for the software productivity improvements kind of got me really paused, because you can only do this kind of things when you're big. And most of the people in this room probably work for a company where this kind of machine learning based test selection, it simply doesn't make sense as ROI. Like it's probably it feels like a science project to you, right? So maybe the world is getting to the direction where the scale actually drives the productivity improvements. And when I think about the fact that Facebook and Google and so on seems to be having this unparalleled productivity that the rest of us doesn't seem to manage to catch up, it seems like it's pointing to that direction. And I don't know if I'm happy about that. But then if you look at in manufacturing and so on, this is already going on, right? Like you can't create a new car company because there's a scale benefit. And maybe the software development is heading that way. So on that note, I wanted to kind of wrap up this presentation and maybe open up for the Q&A. Thank you.
Okay, we'll take a couple of questions also. So raise your hand, please.
Cool. So can you elaborate on that last point? Did you say that you think that scale? What are more your thoughts on scale versus how startups compete with large companies?
Yeah. So I used to think, the small team of the elite developers. Let's overemphasize this a little bit, right? So a small team of elite developers could outmaneuver like a large big companies because we can move faster and they are slower. That was sort of like my mental picture. But maybe I started to wonder if this is the case. Maybe the software development world is heading more like manufacturing world is, where like a small number of people can produce cars simply because there's no, it's a scale business, right? So, this kind of data, if this kind of data-driven development is like as real as I think it is, then, the larger the corpus, like a larger group of people you have, the better you can make them productive, and that's a kind of self-feeding cycle. And then that'd be a sad world if you ask me, but that seems to be like, so that was my pitch. Yeah, does that make sense a little better? Yeah.
Any other questions? Nope. Thank you.
All right. Thank you very much.